Okay, hello class. Ito yung na-miss nating meeting nung Monday. That's April 11. No? And discuss natin kahit pa paano. Kasi mas madali ito kaysa magbasa, di ba? Nakapagod magbasa. So let's have a discussion, a little bit of discussion to understand this chapter. Okay, from last time, ano bang diniscuss natin? So yung diniscuss natin from last lesson is electromagnetic induction. Okay, so ang nangyayari doon kapag may changing flux, meron kang induced EMF. And then if you have an induced EMF, meron kang induced current. Okay, and then the direction of that current is determined by Lenz's law, which tells us that nature doesn't like change. So kapag naglagay ka ng extra magnetic field on a conductor, magpo-produce yung conductor ng current in such a way na ikokontrahin nyo yung change na yun. Okay? So, tinignan natin that whenever we have a current loop, say a current loop, ayan, itong pink, and then there is some magnetic field outside. Okay, kuwari ganyan yung magnetic field natin, yung blue. And then, alam natin merong induction na yung nangyayari. Okay? And then, this scenario is everything we need, di ba? You have a conductor, you have a magnetic field, na-solve mo na, okay na. But let's take a look, a deeper look. No? Paano kapag meron tayong dalawang coils of conductors or loops of wires? Okay, so yung isa may current, isa wala. And then, ayun, dinagdagan mo yung current dun sa kabila. Okay, so parang ganyan itsura nung loop na may current. So magpo-produce siya ng field and then maapektuhan niya yung itong dito, kabilang loops of wire kung marami sila. Okay, so alam natin paano may induce na direction ng current and the amount of EMF that is induced. Kasi di ba alam natin na E mas equal to negative change in time of the flux. Tama? Magnetic flux. Okay. So, we have it like that. Alright. So, tingnan natin itong example. Okay. So, walang bagong math dito. We'll just try to understand things a little bit further. Alright. So, we have two set of loops of wire. Okay. Dalawang coil. So, si coil 1 and coil 2. They're not connected, no? They're not connected. So, si coil 1, meron siyang N1 turns, and then si coil 2, meron siyang N2 turns. Okay? Let's say that coil 1 has a current I1 flowing through it. Putol lang yan kasi tinitingnan natin yung medyo cross-section para mas madali imagine yun. Pero circular yan, syempre. Okay? Meron nagpo-flow na current sa coil na ito. And then, syempre, when we have a coil of wire, and when we have currents, we have magnetic fields. So, si coil 1, meron siyang pinoproduce na magnetic field. B. Okay? B. Now, syempre, meron tayong katabing loop. Therefore, this loop experiences a flux kasi meron siyang enclosed na area and merong magnetic field na nagpa-pass through sa kanya. Okay, so the induced EMF on this second loop, let's say E2 must be equal to negative d over dt ng flux that it is receiving. Okay? And then, since meron kang N2 turns, multiply natin to by that amount. So, we have times N2. Okay? So, we have that. All right. Okay. Now, si phi or the magnetic flux, is dependent on a lot of things, di ba? Pwede siyang dependent sa current, pwede siyang dependent sa area, pwede siyang dependent doon sa magnetic field that it is receiving. Okay, so himayin natin kung saan siya talaga dependent. Okay, so si phi, alam natin to. This is somewhat magnetic field times area, tama? So area and magnetic field yung dependence niya. Yung area ng loops natin, they won't change, okay? They won't change, okay? Ayan na talaga sila. So alam natin, area is constant. Therefore, B has to change if the flux has to change, okay? Okay, so B can change, no? And saan yung dependence ng B? Okay, saan yung dependence ng B? So si B, dependent siya dun sa current, di ba? Just like our electric fields, ang electric fields dependent siya sa mga charges. So si B, yung dependent siya dun sa fundamental element niya, which is in current. So dun siya dependent. And then si B ay coming from I1. So if we change I1, we therefore change the amount of flux going through this second loop. Okay, let's say that this quantity, pwede natin pasok yung N2 doon sa loob ng derivative, tapos wala namang mangyayari sa kanya doon kasi constant lang siya, lalabas lang din. Okay, let's say that that quantity can be equated to a function that is dependent on the current I1. So si current I1 ay yung current na nagpa-pass through dun sa unang loop. Okay, what is M? So, ito ay, sabi kasi natin, alam natin si phi na mag-change lang siya pag nagbago yung current. So, gumawa tayo ng something like this. PB2. Okay. So, sa function ng current. Okay. So, alam natin yun. So, syempre, pinakamadaling function na pwede natin ilagay is I1. Diba? And then, lagyan lang natin siya ng constant M21. Na ibig sabihin na ito yung constant na nasa property ni 2 that is coming from 1. Okay? Okay, so itong M21 na to, tinatawag natin siyang mutual inductance. Okay? Mutual inductance. So let's try to use this in our equation. Now, pansin natin that E2 must be equal to negative D over dt times yung M21 I1. And we know M21 is just a constant. Si M21 yung mag-hold ng iba't ibang constant na meron dito sa equation na to, no? Kasi hindi naman talaga natin alam kung ano kung paano nagre-relate si phi kay I. Alam lang natin na they are both related. So when phi changes, I changes. Okay? So kaya tayo gumawa ng constant M21 para siya mag-absorb lahat ng hindi natin alam. Okay? So you can do that. You can always do that. There's no harm in doing that. So I have here magiging negative M21, then D I1 over D. Okay, so we have this. It turns out na kapag binaliktad natin yung system, no? Let's suppose that the coil number 2 has the current and coil number 1 has no current, doesn't have current. It's magandang grammar. It turns out that this constant M is just the same for both coils. Okay? You can do it by yourself, pero okay na yan. Sige. Okay, so that very useful sa atin yun kasi when we have a setup, so si M, nagdedepende lang siya sa setup mo. It doesn't depend on the amount of the current that is inserted, no? Nagdedepende lang siya doon sa M, sa ano natin, setup natin. Okay? So for those loops of wires, isa lang yung M, isa lang yung mutual inductance. Ayan. So yung mutually induced EMFs, E2, yan, yung na induced na EMF sa coil 2 will just be dependent on the change of current times yung M natin, yung mutual inductance. And similarly, for the other one, kung meron na current nagpa-pass through dun sa coil number 2, si coil number 1 magkakaroon ng induced EMF which is this amount. Okay? Okay. Okay. So, and then si mutual inductance, ito yung ano niya, ito yung itsura niya. So, si mutual inductance equal siya sa N2 phi B over 2 B2 then divided by the I1. Okay? Ano sinabi ko kanina, hindi dependent sa current. Kasi si phi dependent siya sa current, di ba? So magka-cancel lang siya in general. Tapos, ayan, magiging geometric dependence na lang itong dalawang to. Okay? So ayan, itong part na to, equal lang siya dito. Okay? Parang ano no, parang hirap imagine na, sir, but paano sila mag-equal? Pansinin nyo for this example na yung flux nito, the magnetic field, yung coil 1, hindi siya totally, hindi lahat yun papasok sa coil 2. Okay. And then, kapag binaliktad mo naman yung case, ito yung nagpo-produce ng magnetic field, ang mangyayari naman, onti lang yung pumapasok dito na flux kasi, maliit lang yung magnetic field na mapoproduce nito. Okay, so mag-equal lang din sila in the end. Okay, again, you can try it by yourself para makita mo yung mangyayari, di ba? Pero as non-physics majors, you don't have to do this. You don't have to go through the process of doing that. Okay, let's try this example. Meron tayong Tesla coil. And then we have a long solenoid with length L, this guy, the yellow one, and a cross-sectional area A that is surrounded by an N1 turns of N2 turns of wire. Okay? So yung unang loop, yung yellow, would have N1 turns, and we are asked to find the mutual inductance of this system. Okay? How do we do this? Let's find first the phi. Okay? So si phi ay B times A. Okay? And then alam natin na pag solenoid, okay, pag solenoid, alam natin na B is actually mu naught N I. Okay? So the current, the magnetic field, is dependent on the number of turns per unit length times the current. Okay, and then the mu naught constant. Okay, solenoid to. Alam na natin to dapat. And then the area, we're given an area which is A. And then hindi tayo binigyan ng N. Okay? Tayo binigyan ng N. Pero binigyan tayo ng mga number of turns, tapos binigyan din tayo ng length. So we can just have it something like this. Equal siya sa capital N divided by the length. Okay? Okay. Okay. So alamin natin yung flux doon sa N2. This is smaller one. Okay? Alamin natin yung flux doon sa smaller one. And that would be given by flux number 2 must be equal to B1 tapos times A. Okay? Kasi parehas, sinabi sa atin na yung the second coil is meron magkalapit lang yung yung closely wound na pagkaka-wound sa wire na yun. Okay, so pwede natin siyang gamitin pa rin in approximation. Okay, bakit si B1 yung gamit natin? Kasi ayun lang yung magnetic field natin, di ba? Okay. So, therefore, si C would become mu naught. So this is capital N1 divided by the length times I times A. Ano ba? Okay? Very straightforward pa. And then, ang mutual inductance, paano siya kunin? So by this. Alam na natin si number of turns. Alam natin yung, well, suppose natin may current na lang tong si I1. Na I, capital I. Di ba? You can always do that. And then, let's just plug the things we know. Okay? VB2 all over I. Okay? So, N2 times this guy, mu naught, N1 times A times I all over L times I. Then we cancel I. Then therefore we have mu naught N1 and 2 A over L. Okay? Okay. Alright, so that's how we get mutual inductance. As you can see, kung ulitin mo yun sa part na yun, kunwari maglagay ka ng current dito sa N2, N2 na N2 na coil, you'd actually end up with the same amount of mutual inductance. Okay? So anong silbi nito sa buhay natin? Dito nanggagaling yung dito nanggagaling yung tawag dito. Yung mga wireless charger natin. So, well, 'di ba, meron tayong ganyan. Meron tayong charging dock. Okay, so merong coils of wire inside. Okay? Then yung phone mo, meron din coils of wire. So kapag pinatong mo dyan yung phone mo, then nag-pass through yung current, merong induced EMF doon sa loob ng phone mo, magcha-charge siya ngayon. Okay? Amazing, no? Ayan. So, si inductance, ayang M natin, mutual inductance, ang units niya is in terms of Henrys. Henry? I think it's, okay. Let me just check it out. So, ayan ang units niya, Henry. Hindi ko lang sure kung tama yung spelling. Okay, tama siya. American yung mamaya kasi hindi American. American spelling. Pero ayun, Henry siya. Okay, sige lang. Ayan yung units niya kung sakaling nag-wonder kaya. Okay? And then, okay. Pansin natin merong merong nanggaganap kapag merong kang dalawang coils of wires. Okay? What if joined sila? Joined. So, yung nagpapass through ng current dito, nagpapass through rin dito. So, baka nag-wonder na kayo kanina pa nun, no? Paano kaya pag connect silang dalawa? Wari, ito yung mga loops na to. Wala ba silang inductance na ginagawa dun sa kapwa wires nila katabi nila? It turns out, yes, meron silang ginagawa. So when you have something like this, may coil of loop pa. May coil of wire. Coil of loop. Okay? So ayan, meron kang wire kunyari. Tapos nagpa-pass through ka ng current sa kanya. So itong unang loop, syempre magpo-produce siya ng magnetic field, di ba? Produce siya ng magnetic field. And then makaapektuhan yung kabilang loop. Then maapektuhan yung kabilang loop, and so on and so forth. Mapansin mo, it induces itself. Di ba? It induces itself, and we're gonna call that unit kanina mutual inductance. Ngayon, tatawagin na natin siyang self-inductance or simply inductance of a coil. Okay, so si inductance, ito na yung nilelet natin na itsura ng ng function niya. So that would be L, and yung symbol natin for inductance. Then it must be equal to the number of turns in the coil. So for this guy, 5. Tapos flux through itself. Flux through itself, okay? So may magnetic field siya, meron din siyang area. So ano yung amount of that flux? Then there's a current in the coil, and isa lang yun kasi isa lang yun naman yung current na dumadaloy sa kanila lahat, di ba? And with that, the induced EMF is like this. Okay, negative L di over dt. Okay. So ano nangyayari kapag meron kang inductors? Para naman meron siyang implication sa buhay natin. When you have a circuit, let's say, let me draw a circuit here. So this is a source, tapos lagyan natin resistor. At sabihin natin na meron tayong I don't know what the symbol is. Yan na lang. Light bulb. Light bulb yung kunyari mo. So this is the light bulb. So this is a source, and you have a resistor, and you have another one here, which is a light bulb. Okay, so yung source natin, kunyari, ganito yung itsura niya. Ganito yung itsura niya. Okay. Actually, palitan natin yung source natin. Gawin natin current source. Okay, so sabihin natin na ganito yung itsura ng current. Tapos, so anong ibig sabihin ng ganitong current? So this is the current with respect to time of the source. Okay, so nangyari lang, from some time ago, 0 siya. Then at time 0, binuksan natin yung current source. Okay, nag-switch tayo, nagpindot lang tayo ng switch. At time 0, bumukas yung current source to this amount I naught. Okay. Mapansin mo na kapag tinignan mo yung current through the light bulb, you'd actually see the same graph. Okay? And that makes sense, di ba? Okay, ganun lang naman siya. Di ba? Ganun lang naman siya kasi it has to be like that. However, things change kapag nilagyan mo ng inductor yung system. Kuwara naglagay tayo ng extra inductor dito. So yung symbol ng inductor, ganyan siya. Okay. Correct, naglagay tayo ng inductor doon. Ang mangyayari sa kanya, nade-delay yung current. Kung nade-delay yung current, ano yung tsura nun? So, ideally, gusto na ang mangyayari sa current kung walang inductor, katulad lang nito. However, kapag nilagyan yung inductor, magiging ganito siya. Okay. So, it doesn't go up as fast as the circuit without the inductor. Okay, bakit ganyan? Kasi, di ba, mapansin mo, kung sa natin lesson, induction, ano nangyayari pag binuksan mo pag may field na nagbabago, ayaw ng system natin yun. So, magpaproduce ng counter current. Para ito, yung unang daloy ng current. Ang gagawin ng other loops, kukontrahin nila lahat yan. As it passes through. Okay? Kaya slow yung build up niya papunta dun sa I naught na value. Okay? Amazing, di ba? Okay. And to think, no? Galing kasi ito ay wire lang. Inikot mo lang siya na wire. Di ba? Nothing special about the wire. Ang ginawa mo lang, nilagyan mo lang ng change in geometry. Binalot mo lang siya, inikot mo lang siya. And then, it can now affect the current inside your circuits. Okay, anong silbi ng inductor sa buhay natin? Sa mga charger nyo, may makikita kayong parang cylindrical part sa laptop, nasa laptop charger, makikita yung cylindrical part ng somewhere in your charger. Ang nangyayari doon, may inductor sa loob mo. So kapag sinaksak mo yung kuwari ito yung graph, yung nararamdaman ng charger mo. Sinaksak mo yung charger mo and then nag-spike. Kuwari ito yung hindi ba sinasaksak and then nag-spike, kumislap, gumanon siya. So, nag-spike yung current kasi kumislap na, hindi natin alam kung bakit. This is T. Kapag may inductor ka, anong gagawin ng inductor? Ililesen niya yung effect na yun. So, hindi masira yung mga circuitry sa loob ng laptop mo and ng charger mo. Ganun lang siya. I-delay niya. Ganyan lang siya. Amazing, no? Amazing. Minumute niya yung effect ng mga bagay-bagay. Okay? Amazing. And then, just like capacitors, they store energy. Tignan natin yung mamaya. Pero dito muna, inductors in series and parallel, yung L natin, may similar relationship siya sa katulad sa resistors. So, series ng L, that would be L must be L total. Hindi ko alam kung lalabas sa exam pero turo na natin. L2, L3, that. Pero hindi naman kayo mag-analysis ng para inductors in circuits kasi mahirap siya. Hindi siya normal. Hindi siya madaling . And then for parallel, for parallel connection ng ito ay ganito. Diba? Katulad lang dun sa L3 and so on. Okay? Ang pangit ng font. Dapat pink. Ayan. Okay, so ganyan lang siya. Okay. And then, as I've said a while ago, the inductors, they carry energy, just like your capacitors. Okay, so the energy stored in an inductor is given by this one. Okay? So, LdIdt. Tapos, we try to, that's the voltage, di ba? Tapos, solve nyo na lang yung energy gamit yung voltage. So on, pero no need to do that again. Pero ang maganda dito, similar siya sa form nung sa capacitors. So you have 1/2 Li squared. Yung sa sa capacitors, 1/2 CV squared. Diba? Very similar in looks. Okay? And then, meron tayong tinatawag na magnetic energy density, which is small u, kasi density siya. So if you're gonna get the total energy in some region with this amount of magnetic field, then you have to multiply this whole thing by a volume, kung saan yung volume na inoccupy ng magnetic field B. Okay? Basically, there is energy in your fields. So sa B squared, doon yung yung energy mo. Okay? So nothing else, constants lang tong mga to. Okay, is this too different? No. You can actually get the other one using this and the other. Well, syempre, this is a specific case of use of inductors, di ba? So, pwede mo gamitin papunta sa kabila. Kabila papunta dito, parang too much effort. Pero, ayun, they point to the same quantity, energy. Okay? Ito ay energy density. All right. I think this ends the topic for the second exam. So, you talk among yourselves kung kailan tayo mag-e-exam. Okay? How flexible naman ako kailan nyo gusto mag-exam. Pero, ayun, alternating current circuits, di natin sila sinama. And waves, electromagnetic waves, hindi na rin. I think sana hindi siya, kabilang klase hindi magbigay ng questions regarding that. If ever magbigay ng questions, I should inform you beforehand, no? Kasi I could see the questions naman beforehand, the exam. And then, ayun, madali lang naman kasi makikita mo sa book yung mga examples. Okay, so we can try the problems in advance. Okay, so the bulk of the second exam would rely on your skill on Ampere's law, Lenz's law, and what else? Actually, marami sa Ampere's law, no? And forces, magnetic forces. Itong ano pala. Marami sa magnetic forces. Yan. Motion ng charged particles. So, maraming right-hand rule na nakakalito siya. So, you have to be careful of things. Okay? And magpo-post pa ako ng prob sets para naman panghatak pa tayo ng grade. Okay? Okay, so I guess that's it. Thank you. Let's see next week. Goodbye.